Hydrogen cyanide. Hydrogen cyanide is a colorless and flammable liquid that easily evaporates under normal conditions. Its boiling point is 25.6 Celsius. It smells like bitter almonds. HCN is important in industrial processes. It has numerous applications including synthesis of polymers and metallurgy. Naturally, it is produced in some plants, the seeds and pits of Prunus species. Hydrogen cyanide intoxication is usually accidental. It is most often caused by the breathing in of smokes from burning materials containing carbon and nitrogen. HCN can be released during industrial plating and polishing of metals if cyanide metal salts are mixed with acids. It is also contained in cyanide-based insecticides. It is also in the exhaust gases of vehicles, tobacco, and wood smokes. Hydrogen cyanide intoxication can be intentional. The infamous Cyclone B was used in gas chambers during the World War II genocide. Hydrogen cyanide is a highly lethal chemical asphyxiant. The concentration of 135 ppm is lethal after 30 minutes. As for each cyanide, its toxicity is metadated by the cyano group. Once it enters the bloodstream, the cyano group is released and binds to its target molecules within a few seconds. Irreversible binding to the ferric ion in the heme subunit of the mitochondrial cyclotron oxidase A3 is the most important. The CN anion acts as a non-competitive inhibitor of this enzyme. Interrupts oxidative phosphorylation, stops AT production, and the aerobic cell metabolism. Oxygen cannot be utilized at the cellular level. As a response, the metabolism quickly shifts to the anaerobic glycolysis. Clinical manifestations appear within the first minutes after inhalation. They are quickly followed by seizures, decreased consciousness, coma, and death. Despite oxygen accumulation in the venous blood, a profound hypoxia rapidly rises. It leads to extensive cardiovascular response. HCN is an extremely poisonous substance, and acute intoxication requires very rapid management. Rescuers must ensure their own safety. Evacuation and contaminated clothing removal are needed. A cyanide antidote is administered as soon as possible. The cyanide antidote kit contains amyl nitrate for initial quick inhalation and sodium nitrate, and sodium thiosulfate, both for IV application. Both nitrates bind to hemoglobin, producing methemoglobin, which has a higher affinity to cyanide than cryochrome oxidase A3. Methemoglobin scavenges cyanide, forming cyanide methemoglobin. Functional mitochondria and cell respiration are restored. Sodium thiosulfate binds extracellular cyanide, forming thiocyanate, which is excretable by kidneys. Disadvantages of this therapy are vasodilation with hypertension induced by nitrates and decreased amount of functional hemoglobin. Hydroxycobalamin, which is a more recent alternative, seems to be more favorable. It binds cyanide, forming the non-toxic and renally excretable vitamin B12.